Hello students, you're welcome to this video on angles and polygons. This video is for grade 8 students, and this will be the first part in this series on angles and polygons. I want to say you are most welcome. Now in this video, the objectives that we have will be that at the end of the video you should be able to identify, to name, and to calculate angles on a straight line. Secondly, you should be able to identify and name and calculate angles meeting at a point. And finally, you should be able to identify and name and calculate angles involving a transversal and involving parallel lines. Okay. Now we'll start with angles between lines. Angles are formed when two or more lines meet. You see, every time that two or more lines come in contact with each other, an angle is formed. Now, the spot where the angle is formed is called the vertex. But what is formed when two lines or more lines come together or come in contact is called an angle. Now, let's say that this is a line. We have an horizontal line like this. And then let's assume that a vertical line makes contact with that horizontal line right here. Then an angle is formed here and on the other side as well. Okay, every time that two lines come in contact with each other, an angle is formed, and this is an example of that. And it doesn't even have to be a vertical line. For example, if we had this line before and then there is a slant line that comes in contact with it, then an angle is formed right here and also at the other side here. Okay, so every time the two lines meet, there's always an angle formed. Okay, if you have this line as well and another line which is also horizontal comes in contact with that line like this, yet an angle is formed. Sometimes students assume that there is no angle between these two lines, but certainly there is an angle. There is an angle up there, and of course there is one down here as well. Okay, so it's important to keep that in mind. Next is to know that a protractor is a tool that is used to measure an angle, and this is what a protractor looks like. I'm sure you have seen this before in your mathematical sets. This is what a protractor looks like, and this is what you use to measure angles. Okay, so you can see it runs from 0 in the inner and the outer scales. You have 0 down to 180 right there, like that. So now let's look at how to measure an angle with a protractor before we start to do that. The first thing you have to do is to place the midpoint of the protractor on the vertex of the angle. Remember, I said vertex is the point where the angle is formed. Okay, it is the place where the two lines meet. Okay, that's where the vertex is, and then an angle is formed at that spot. So you put the midpoint of the protractor on the vertex of the angle, and then secondly you line up one side of the angle with the 0 line of the protractor. So you see the number 0 on the protractor. You align one side of the angle with the 0 line of the protractor, and then you read the number of degrees where the other side crosses the number scale. Now you have one side of the line, you place your 0 directly on that line, and then you read at the other side where the second line that formed the angle crosses the number scale on your protractor. All right, and this is important. You must take care to read from the right set of numbers. A protractor has two sets of numbers. One set goes from 0 to 180 and the other from 180 to 0. And the one that you read depends on how you place your protractor. So you ensure that you can use one of the two scales, to read your angle and read it correctly. Okay, now to measure this angle on your screen, we have two lines. We have an horizontal line and we have a slanting line that has made contact with that horizontal line right there, and we want to measure the angle that is formed. When two lines meet, an angle is formed, so we want to measure the angle formed right here. What I have to do is to place my protractor in this manner. So you see that the midpoint of the protractor is right on the vertex of the angle formed. And then if you look at the inner scale of this protractor, you'd see that the line of 0 on your protractor is directly on one of the sides of the lines that forms the angle. This is really very important. And then I'm going to read at the other spot where it crosses the scale. All right, so here you have the side that lines up with 0 degrees in the inner scale. So I'll be using the inner scale for my measurement, because for the inner scale I have 0 here. Okay, it's important to note where you are starting your 0. Okay, that's what determines the scale that you'll be reading for your angle. So if you look at the second line up there, you can also see that the line intersects with 45 degrees on your protractor. So it means that the angle formed here is from 0 to 45 degrees, and therefore the angle formed between the two lines is angle 45 degrees. And this is really so easy for you to do. You can practice it at any point in time on your paper. You can draw two lines that form an angle, and then you use your protractor to measure that angle. It's really very easy to do. Now let's look at this particular one. We have two lines that has formed an angle right here. You have an horizontal line and a slanting line that has made contact right there. Of course, an angle is created, and for us to be able to measure this angle, then we have to place our protractor like this. You see, so it won't matter if you have to turn your protractor upwards or downwards, to the right or to the left. The point is, one of the two lines must be on 0, like you have right here, and then you measure the angle formed by the other line. But always note that you have to read the right scale. In this particular example, okay, the outer scale is what we will use, because the side that lines up with 0 degrees is in the outer scale. So we will measure the angle using the outer scale right from 0. And if you look at the other one here, you realize that on the outer scale you have 140 degrees. It means that the angle formed between those two lines will be 140 degrees. Okay, so it's really a fairly easy task to perform. So what is the angle that is shown in this diagram on your screen? I'll give you a moment to think about that. What angle is formed by these two lines right here? Okay, it's also quite easy. You would see that your horizontal line is aligned to the 0 degree of the inner scale. It means that we'll be using our inner scale in measuring this angle. Now, if you follow your inner scale, you'd see that the line has gone past 70. You have 70, you have 71, and the line is on 72. So that means that your angle is 72 degrees. Do you understand that? Okay, you have 0 here, you have 72 for the other line, and so the angle formed by those two lines is 72 degrees. Let's look at this case. We have that horizontal line and we have a slanting line like that. Of course, we're going to use the outer scale, because the outer scale is aligned to the horizontal line on 0, and so we follow the outer scale until we get to the second line, and what I have here is 50. So that means that the answer to this is 50 degrees. You get the general idea. Okay, so How about this one? I'll give you a moment to try to figure this out. Okay, we have two lines. We have an horizontal line aligned to 0 in the inner scale. It means we're going to be using the inner scale to determine the angle formed by these two lines. And if you follow the inner angle, you realize that this has gone past 120. So you have 121, 122, 123, 124, 125, 126, and 127. So it means that the angle formed here is 127 degrees. Okay, so basically that's how you use your protractor to find angles. Now we move to angles on a straight line. Angles on a straight line. Now, if you have this line, okay, you have this horizontal line, and then there is another horizontal line that meets it, that joins it, is also an horizontal line. So when the two lines meet, they essentially become a single straight line. You can see that it's difficult to know the point of intersection between the two lines. Okay, so this is a straight line, and it could even be a single straight line, but we have a straight line right here. And we want to know what is the angle on this straight line. What's the angle between this line that was right here and this other line that joined it right here? What's the angle between them? And what I have to do is to set my protractor like this. Now, if my protractor is set like this, I could decide to start either from the right hand or from the left. I could use the outer scale or the inner scale. You see, because on both hands you have 0 coinciding with one of the lines. So I'll use the outer scale anyway. I use the outer scale, so it means I'll be starting from my left hand side, and the outer scale is 0 at the left hand side. So I follow the outer scale until I get to the second line right here, and that would be 180 degrees. It means that the value of that angle, I'll call it theta, and I'm sure you know that we use Greek alphabets to represent angles. Theta, alpha, beta, gamma, and things like that are used to represent angles. Anyway, so the angle between these two lines, which has formed a single straight line, is 180 degrees. Now, what if I introduced another line like that, a vertical line which is perpendicular to the straight line that I had initially? Well, then it means that if I start from my outer scale, okay, from this point here up to this new line that has been drawn will give you 90 degrees. And then I come to the other side, which is the right hand side. I'm going to use the inner scale right now because I'm starting from 0 right here. And then from this 0, I follow the inner scale until I get to this line once again. And what I have is another 90 degrees. So it means that the angle between this line right here through the vertical line down to this other line right here will be 90 degrees from this side plus the 90 degrees from this side, which also gives me 180 degrees. Okay, now I could also decide to introduce another line like this. Okay, and this slanting line has also divided the straight line that I had initially into two angles. I'm going to start from my left hand side first and foremost. You have 0, and by the time I follow the outer scale to the slanting line, I have 40 degrees. Okay, then I come to the right hand side. I'll be using the inner scale now, and if I start from 0 right there and go up to the line, I'll have 140 degrees. So what that implies is that the entire angle between this line right here and this line right here would be 40 degrees plus 140 degrees on the other side, and that will also give us 180 degrees. Basically what that implies is that the angles on a straight line add up to 180 degrees. So every time you see, it might be divided into 2, it might be divided into 3, or even more. As long as all those angles are on a straight line, adding them together will give you 180 degrees. That's really very important. You have to keep it in mind. Now let's look at an example or more. We have this line right here, or these lines right here, and we are to find the value of angle A. Now the straight line has been divided into two angles. You have A on one side and 50 degrees on the other side. Obviously we are aware that the sum of angles on a straight line is 180 degrees, and what that implies is that if we had A and 50 degrees together, we get 180 degrees. And if that is so, then A would be equal to 180 degrees minus 50 degrees, and the value of A will be 130 degrees. 130 degrees. You got that perfectly, right? Now let's look at another one. We have these other angles that are formed on a straight line. The slanting line divides it into two. You have B and 137. Of course, we follow the same procedure. Sum of angles on a straight line is 180 degrees, and that vertical line is obviously a straight line. So it means that if I had B and 137 degrees, I'll get 180 degrees. B would be equal to 180 minus 137, and that will give me 43 degrees. So the answer to that is 43 degrees. And last but not the least, I have these diagram. I'm to find the value of angle C. Now the straight line has been divided into three angles. There are two slanting lines that met at the same point on that straight line. Of course, we are also aware that the sum of angles on a straight line is 180 degrees. So it means if I had C and 90 and 67, I'll have 180 degrees. Of course, if I had this together on the left hand side, I will have C plus 157 is equal to 180 degrees, and then move 157 to the other side. C would be equal to 180 degrees minus 157 degrees, which will give me 23 degrees. So the value of C will be 23 degrees. It's an acute angle as well. Okay, so this would be your exercise. You have exercises 1, 2, and 3. You have to find the value of the unknown angles in the diagrams below. Okay, 1, 2, and 3. I would expect that you do that and you'd send to the emails. I'll give you the emails at the end of the video. Alright, ensure to do them and send them in at the right time. Now let's move on from there. We'll be looking at vertically opposite angles. And we'll start by considering this line right here. We have a slanting line right here, and then we have another line that crosses that initial line. Remember, these are straight lines, okay, but now one is crossing the other, and we want to measure the angle formed at each side. You know, of course, we know that this right here is a straight line, and the sum of angles on that straight line is 180 degrees. That has been established. But now we want to see how it is divided. It's divided into two. So what angle is on this side and what angle is on the other side? Okay, of course I'll place my protractor like that. So my protractor would be on that line, okay? And from here, right here, I'll be using the outer scale on the left hand side. So I follow the outer scale, it's 0, and if I follow it up till this other part, it means that I would have gone 100 degrees. So it means that I have 100 degrees on this side of the divide. And then if I start from the right hand side, I'll be using the inner scale now from 0, and it goes up until 80. Okay, it means that on this side I have 100 degrees, on this side I have 80 degrees, which makes total sense because the addition of those two angles should be 180 degrees. So I will impute that. Right here you have 80 degrees, and right here you have 100 degrees. That forms 180 degrees for this straight line right here. Next, I want to also measure the effect of this line on the other straight line. I want to measure, of course, we also know that this line is a straight line as well, so the sum of angles on it should be 180. All right, but let's turn to the other side. Okay, I want to turn to the other side and see what angles are formed at the other side of this line. Okay, so what I'll do is to turn my protractor in this manner, and in doing that, I'll start from my right hand side and use the outer scale to check out the angle between this line right here and this line right here. And if I follow my outer scale, I have 0 up till 100. Okay, 100 degrees. And then I'll go to the left hand side and start with the inner scale. And for the inner scale, I have 0 up till 80. It means that I have 80 right here and 100 right here. So I impute that as well. Did you notice something? You'd realize that the angles that are vertically opposite each other are equal. And that is it. When two straight lines cross over to make an X, each pair of vertically opposite angles are equal. This is really very important. Okay? The pair of vertically opposite angles, anytime two straight lines make a cross to form an X, the two opposite vertically opposite angles are equal. So if this was 100, then this would be 100, and if the other one was 100, then the other would be 100 as well. Okay, now let's look at an example on this. If you have this particular diagram, and you are to find the sizes of all the missing angles. But to find the size of angle X, find the size of angle Y, and the size of angle Z. And in the diagram, we are given 146 degrees for the fourth angle. Obviously, we are aware that vertically opposite angles are equal. It means that our X will be equal to 146 degrees because that's the angle that is vertically opposite the angle given. So X equals to 146 degrees. And also, we know that the sum of angles on a straight line is 180 degrees. And if that is true, it means that if we had Y and 146 degrees, we should get 180 degrees, because you see right here you have a straight line, and those two angles are angles on a straight line. So if I add them together, I should get 180 degrees. It means that Y would be 180 degrees minus 146 degrees, and that should give me 34 degrees. Okay, so the value of Y is 34 degrees. And of course, for me to get the value of Z, Z will also be equal to 34 degrees, and you know why that is so. The reason is because it is a vertically opposite angle to Y. Okay, so we've gotten the values of X, of Y, and of Z. Okay, and we used all the laws of the lines, or the angles formed between lines, to be able to determine the values of these angles. X is equal to 146 degrees, Z equals to 34 degrees, and Y also is equal to 34 degrees. Okay, so now let's move on to the angles at a point. What will be the value of a angle at a point? And we're going to start with this point right here. We want to measure the angle that goes all around this point. The angles, if we turn completely around this point, what will be the angle formed? So now I'll draw a straight line through that point, and we obviously know that the upper part of this straight line has an angle of 180 degrees, because the angles on a straight line is 180 degrees. Okay, and if I turn to the other side, obviously the lower part, that's 180 degrees. The lower part as well is the sum of angles on a straight line, which would also give me 180 degrees. And if that is so, it means that the angle that I'll find if I turn around this point is 180 degrees plus 180 degrees, and that will give me 360 degrees. It means that the angle at a point is equal to 360 degrees. Okay, the angle at a point, the sum of angles at a point, it adds up to 360 degrees, and this is also really very important. All right, so now I'll give you a second set of exercises, and there are 4 of them this time. You have to find the values of the unknown angles. So in the first question, you find the value of A, the second B, the third C, and the fourth you find the value of D. You're going to submit it along with the first exercise as well. I'll give you the email to send it to forward it to at the end of this video. Now let's look at the angles that are formed between parallel lines and a transversal. First and foremost, let's define what a transversal is. A transversal is a line that joins 2 parallel lines. A transversal is a line that joins 2 parallel lines. And then what's a parallel line, or what are parallel lines? Parallel lines are lines that can never meet because the distance between them remains constant. So if the distance between 2 lines remain the same, no matter how long you drag them, it means that those 2 lines will never meet. Okay, and that makes them parallel lines. Okay, so now let's have this line, which I'll call line A, and then would have another line which will be line B. Now these 2 lines are parallel. You can see that the distance between them, even without measuring, you can see clearly that the distance between these 2 lines remains constant. And if you continue to drag them on and on, they will maintain the same distance between them, and that makes them parallel lines. And then I'm going to have a transversal, which will be a line that joins both together. Okay, that's a transversal. I'll call C. And maybe let me just label that. Lines A and B are parallel lines, and line C is a transversal. Okay, anytime you see something like this, you have 2 parallel lines and then a transversal that joins these 2 parallel lines together. So the first of these of the angles that is formed between parallel lines and a transversal is what we call the alternate angle. And these alternate angles are always equal. Sometimes it is called the Z angle because it is usually forms a Z. Okay, the angle inside the Z at the top is the same angle at the bottom of that. That they're called alternate angles. So now let's get back to these parallel lines and the transversal. There's a Z angle right here. And I'd like to show you, if you look at this line right here coming from your left towards the right, and then if you look at this line coming from up, coming downwards, and then this line that proceeds like that, you can see that it forms a Z. Okay, and it means that this angle here and this angle here are alternate angles. The angle inside the Z right there is equal to the angle inside the Z right here. Okay, do you understand that? It's sometimes called the Z angle. Every time that you find two parallel lines and a transversal forming a Z, then the angles in here and in here are the same, and those are called alternate angles. So sometimes I call them alternate angles in form of letter Z. Okay, so if we label this angle right here A and we label this one B, then angles A and B are called alternate angles, and that implies that A will be equal to B. So in case you are given the value of A, then you could just get the value of B by saying they are alternate angles. And then of course, if we labeled this other side C and we label this other side D,
Now you can also see that it has its own z as well. Right here, the line comes here, comes down and goes down that way. Okay, which also means that angle C is also the same thing as angle D. So it's important to look out for these when you are given questions to answer, okay, on angles and polygons. Okay, the second kind of angle that is formed between parallel lines and a transversal is called corresponding angles. Okay, corresponding angles, and these corresponding angles are equal angles. Corresponding angles are equal, and sometimes corresponding angles are called the F angle. And of course, you can guess the reason is because somehow you can trace an F where the angles are formed. Now we have these again, parallel lines and the transversal. Okay, and our F, if you see this line right here, and then this other one, you see this line coming here, this one going down there, and then this other one forms a giant F. Corresponding angles, most times they form the letter F. And what this implies is that the angle here is the same as the angle here. Okay, the angle inside the F there is the same thing as the angle inside the F here. Okay, these are called corresponding angles and they are equal. So if we label these ones A and B, then angles A and B are called corresponding angles, which implies that A and B are equal. That is, A is equal to B. Okay, and it's also possible for us to label here C and label here D, and somehow you can also see that there's an F formed, and this time the F is upside down, but then of course it's an F. You can see right here you have these, you have this, and you have that, and that means that C and D are also equal. Okay, this is what you call what's called corresponding angles. Okay, and you must look out for that as well when you're given questions to answer. Okay, the third kind of angle that is formed between parallel lines and a transversal is what we call the opposite interior angles. And these opposite interior angles are supplementary. Supplementary means that they add up to give you 180 degrees. That when you add these opposite interior angles together, you get 180 degrees. Okay, that's what it means, that they are supplementary. And sometimes this angle is also called the C angle. The C angle. Now we have these parallel lines and the transversal, and our C angle is formed right here. You can see this line and this line and the other one. You can see that C that is formed in the middle right there. Okay, so it means that the angle formed here and the angle formed here are opposite interior angles. You know, the meaning of interior means the one that is within, that is inside, and not outside. These are interior angles. The opposite interior angles are supplementary. So it means that if we label this one A and this one B, adding A and B together will give us 180 degrees. Angles A and B are called opposite interior angles, and adding them together will give you 180 degrees. Okay, now it is also possible for you to label these angles C and label the other one D, and once again you can see the C formed, the C shape formed is facing my left hand side. Okay, and it means that if I had C and D together, I will get 180 degrees as well. Okay, this is also very important for you to keep in mind when you have questions to answer. Now let's go through this example. Let's go through this example and then we'll see what happens after. I said find the unknown angles in the diagram below. So we have about 4 unknown angles. We have A, B, C, and D. And of course you have 2 parallel lines and 2 transversals. You can see them. This line and this line, they are parallel lines, and then this is a transversal. It's a line that connects 2 parallel lines, that joins 2 parallel lines, and the other one, this one too, is a transversal. Okay, it's a line that joins 2 parallel lines together, and the 2 transversals, they met together on this side of the parallel lines, and of course they are scattered at the other end of the parallel lines. Okay, so how do we attempt this? The first thing that you should observe here is that angle A would be equal to 55 degrees. And the reason is because they are alternate angles. The angle, you can see the letter Z here, and the angle in here, which is 55, is equal to the angle in here, which is A. So our A is equal to 55 degrees. Okay, if that is so, we can move on. What else do you see here? Angle C will be equal to 180 degrees minus 123 degrees, because C and 123 degrees actually form an angle on a straight line. Is that so? So if you say C plus 123 degrees, you should get 180 degrees. Okay, and of course you move your 123 degrees to the other side, and then that gives us 180 minus 123, and that gives us 57 degrees. The reason is because they are angles on a straight line. And then the next thing that you can also observe here is that angle B would be equal to angle C. And the reason is because they are alternate angles. You can see this Z right here as well. They are alternate angles. Angle B and angle C will be equal, and they both will be equal to 57 degrees because angle C has been established to be 57 degrees, and that's alternate angles. And last but not the least, angle B and D and 55 degrees are all angles on a straight line. B plus D plus 55 degrees should give us 180 degrees. And the reason is because they are all angles on a straight line. You remember, angles on a straight line add up to 180 degrees. So if you put input values, you have 57 plus D plus 55 is equal to 180 degrees. It means if you add up the left hand side, you have D plus 112 degrees will be equal to 180 degrees. And then you move 112 degrees to the other side. So D equals to 180 minus 112 degrees. And the value of D will be 68 degrees. So in solving this single question, I've had to use my knowledge of alternate angles and the knowledge of angles on a straight line combined together. Okay, there may be other ones where you would have to also combine corresponding angles. Maybe other ones where you have to also combine the opposite interior angles. You must keep those in mind. The angles formed between lines. Okay, you must keep all of those in mind so that you are able to answer any question on this particular topic, angles and polygons. Okay, so I'll leave you with the third exercise. Exercise 3, you have to find the value of the unknown angles in these 4 questions here. So you have exercise 1, you have exercise 2, and exercise 3. Okay, and all of them I would expect you to submit before Friday, the 13th of May. Okay, 2020, and you submitted the emails on your screen for SGC and for SHS. All right, and then by the time we are having the interactive classes, we'll go over it so we can ensure that you got you have a very good understanding of the concepts that have been taught. Okay, so thank you very much for your time. This is the first part. This is the first part in the series. There are more things that we will get to discover under angles and polygons. But for now, I want you to ensure that you practice these questions, send in your answers so that I can have a feedback on how well you have understood the things that have been taught. All right, do have a wonderful time. Take care of yourself. Bye-bye.